Hey guys, Miss Terrell here. Today we are looking at isosceles triangles, and I found this really cool picture and I thought it fit right in with what we're studying. So right here, if you look at this, we have numerous isosceles triangles. I'm going to highlight this one right here. So the thing is that an isosceles triangle has two congruent sides, and we're going to be looking at the different parts. So you have congruent sides, the angle between the congruent sides, that is called your vertex angle, and then the other angles across from the equal sides are called your base angles. So down here we have a base angle. This angle over here is also a base angle. The side across from the vertex angle, the side that's not congruent to the other two, that is called the base of your triangle. It doesn't matter which way the triangle is oriented, just between the equal sides, that's your vertex angle. Then you have your base angles across from the equal sides. So this is actually the second part of lesson 4.2. Our essential questions: how do you solve for missing sides and angles in isosceles and equilateral triangles? So let's look at the big ideas for isosceles triangles. The first one, if the sides are congruent in your triangle, then the angles opposite those sides are congruent, and those would be called your base angles. Then we have the converse of that statement. If the angles are congruent, then the sides opposite those angles are also congruent. Finally, we have the big idea for equilateral triangles. So here we know if the sides are equal, then all of your angles are going to be equal. Also, we would know that each angle is going to be 60 degrees. The sum of the angles in a triangle is 180. So if we take that and divide it by 3, we are going to get 60 degrees for each angle. Oh, isn't Louie looking sweet this morning? Look at those sweet little eyes curled up on the couch beside me. He's trying to learn some geometry. Examples: find the value of x, show all your work. So first thing we want to notice here is that the sides are equal. So I'm going to draw a little arrow across from the equal sides. You have to have equal base angles. So I know this one up here is going to be 54 degrees. Then you want to look at your whole triangle. So all three angles in a triangle, what do they add up to? They add up to 180. So I'm going to say 180, subtract what I get when I add 54 and 54. So you're going to have 180 minus 108. So your missing angle is 72 degrees. Number 2, this one's a little bit more interesting. You have two isosceles triangles. So we're going to start with this one up at the top. We're going to look for our base angles. So that would indicate that this other angle over here is 65 degrees. Next, I'm going to find the missing angle right here. So I'm going to say 180 minus what you get when you add 65 and 65 would be 130. So that gives us 50 degrees. Now, moving across to the next vertical angle. Across from that, this angle right here is going to be 50 degrees. Just look at this as like a little puzzle here. We have two congruent sides over here. So these base angles will be equal. So this would indicate a 50-degree angle down here. Then we have a triangle. You know, two of the angles are 50. So we were going to say 180 minus 50 plus 50. That's easy to do in our head, 100. So the final value of x is 80 degrees. In number 3, we're going to need to draw a picture to help us out with solving. It says in triangle QRS. So I'm going to draw QRS. Tells me that angle Q is congruent to angle S. So I'm going to mark that in the diagram. So important to mark everything you're given. SQ equals 5. That means the length from S to Q is 5. RS is 11, so the length from R to S is 11. And we need to find the length of side QR. How long is QR? So if we look at this here, you have these base angles, Q and S, across from your base angles are going to be equal sides. So if I know this side over here is 11, then the side opposite this base angle must also be 11. So our final answer is 11. Number 4, in triangle JKL, so let's draw JKL. Always, always, always draw a picture. It says segment KL, all right, KL is this one here, is congruent to JK. So I'm going to mark those two as equal. The measure of angle J is 17. Find the measure of angle K. So we're looking at this as an isosceles triangle. Across from the equal sides, you have equal angles. So that's going to make angle L also 17 degrees. Now, angle K. We know that in a triangle, they're going to add up to 180. So we need to subtract the sum of 17 and 17, the other two angles that you've already labeled. That will give you 34 degrees, and then subtracting, you're going to get 146 degrees. Bye-bye. Is equal to the measure of angle K. Now, we did problem 5 in the last video, and so that wraps up your isosceles and equilateral triangles. So isosceles, key vocabulary, base angles. If the base angles are equal, then the opposite sides are equal. If your angles are all equal to each other, if they're all 60, then you're going to have an equilateral triangle.